Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on compound interest. If you need any extra help on compound interest, if you go to Corbettmaths and go to the videos and worksheets section, and scroll down to video number 236, there's a dedicated video tutorial there on compound interest. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one says Sebastian leaves £3,000 in the bank for 2 years and it earns compound interest of 2% per year. And we've been asked to calculate the total amount Sebastian has in the bank at the end of the 2 years. So because he's invested £3,000 in the bank for 2 years and it earns 2% per year compound interest, what we need to do is we need to increase the £3,000 by 2% to find out how much money would be in the bank after 1 year. And then once we know that amount, we'll then increase that by 2% to see how much it'll be in the bank after 2 years. So let's do that. So let's start off with the £3,000. To find 2%, well, it's a non-calculator question, so I'm going to divide it by 100 to find 1%. And if we divide it by 100, that tells 1%, that's equal to 30. So that means that £30 is equal to 1%. But we want 2%, so we're going to double that. So we're going to do 30 times 2, and that's equal to £60. So that means that 2% of £3,000 is £60. So that's how much interest he earns in the first year. So that means if we do 3,000 plus £60, how much interest he earns, that'll be how much money's in the bank after 1 year. And that's equal to £3,060. So that's how much money's in the bank after 1 year, but we want to work out how much money Sebastian has in the bank at the end of the 2 years. So now we need to increase this by 2%. So we're going to take the £3,060 and we're going to divide that by 100 to find 1%. And that would be, if we divide that by 100, 30.6, so £30 and 60p. Then we're going to take that 1%, which is 30.6, and we're going to times that by 2 to find 2%. So if we double that, that'll be equal to 61.2. Or remember, we're dealing with monies here, so I'm just going to change it into £61 and 20p. That's how much interest he earns in the second year, because he earns a little bit more interest in the second year, because after 1 year he had £3,060, he had that little bit more money. So that means he earns a bit more interest in the second year. So if we want to work out the total amount of money Sebastian has in the second year, we now just need to add this interest on to the £3,060. So if we do £3,060 plus £61.20, so I'm just going to go up here, £3,060 and £61.20. Just line them up. It's very important with questions like this that you're very careful with your method. I'm just laughing because of that line going across there. So that's a 0, and then yep, and then the line across, and then plus. So 0 plus 0 is 0, 0 plus 2 is 2, 0 plus 1 is equal to 1, 6 plus 6 is equal to 12, so put the 2 down and carry a 1, 0 plus 1 is equal to 1, and then we've got our 3. So at the end of the 2 years, Sebastian will have £3,121 and 20p, and that's how much money Sebastian would have in the bank account at the end of the 2 years, and that's it. Okay, let's have a look at our next question, question number 2. Okay, let's have a look at our next question, question number 2. So question number 2 says, Fiona leaves £1,600 in the bank for 4 years and it earns compound interest of 4% each year. And we've been asked to calculate the total amount of money that Fiona has in the bank at the end of 4 years. So it's a calculator question, so that's quite nice. And remember, for compound interest questions, using a calculator, we can use initial times multiplier to the power of time. So here, Fiona invested £1,600, so the initial amount of money would be £1,600 times multiplier. Well, it's got an interest rate of 4% each year, so if you increase something by 4%, that'll be 1.04 as a multiplier. That's what you'd multiply something by if you wanted to increase it by 4%, so 1.04. And then to the power of time, well, it's invested for 4 years, so it's going to be to the power of 4. So if we type this into our calculator, 1,600 multiplied by 1.04 to the power of 4, that's equal to 1,871.773696. Now here we want to write down the total amount of money that Fiona's got in the bank at the end of 4 years. So that's going to be 1,871 point, and I'm just going to write 77. I'm just going to round that to 2 decimal places because obviously it's how much money she's got in the bank. So it'll be rounded to the nearest penny, and that's it. Okay, let's have a look at our next question, question number 3. Okay, so question number 3. Question number 3 says a car was bought for £18,000. and its value depreciated, so that means goes down, by 15% each year for the first 3 years. And the question says, what is its value at the end of the 3 years? Okay, so again, we're going to use the same formula because we can use these for compound interest questions or those repeated percentage change questions. So initial multiplied by the multiplier, so multiplied by the multiplier, to the power of time. So here, the initial value of the car was £18,000. The multiplier, because it's decreasing by 15%, depreciate means it's going to go down in value, so it's depreciating by 15% each year, so it's going to go down by 15%. So if it starts at 100%, if you decrease it by 15%, you'll be left with 85%. So the multiplier would be 0.85. And then to the power of time, well, it's 3 years, it's going to be to the power of 3. So we just need to type this into our calculator. 18,000 multiplied by 0.85 to the power of 3. And when we type that into our calculator, we get an answer of £11,054.25. And that's it. So that would be the value of the car at the end of 3 years. It'll be worth £11,054.25. And that's it. Okay, let's look at our next question, question number 4. So question number 4 says, Sally bought a piano for £2,200. We're told that each year the value of the piano increases by 11% of its value at the start of that year. So it appreciates by 11% a year. So whenever it increases by a certain percentage, it appreciates, and whenever it goes down in value, it depreciates. So here it's going up by 11% each year. And part A says, find the value of the piano after 1 year. So it's worth £2,200, so £2,200, and it's going to increase by 11%. So we can just multiply it by, well, if it increases by 11%, it's going to then be worth 111%, so it'll be 1.11. And if we just do 2,200 multiplied by 1.11, you could do to the power of 1 if you wanted to here, but it's just going to be the same calculation, and that'd be equal to £2,442. And that's it, £2,442. Okay, and then part B. Part B says calculate after how many complete years the value of the piano will be at least £3,200. Okay, so it was 2,200 to begin with. We times that by 1.11. We increased it by 11%, and we got that was equal to £2,442. If we then multiply by 1.11 again, we get that's equal to £2,710 and 62p. If we times by 1.11, if we increase that by 11%, we get that's equal to £3,008, 0.7882. I'm just going to write down the decimal numbers here. If we actually needed to give it as a particular value, I might round it to the nearest penny, but I'm just going to write these down for the moment. And then if we multiply it by 1.11 again, that'll be equal to 3,339.754902. And as you can see, the initial value of the piano was £2,200, and it took 1, 2, 3, 4 years to have a value of £3,200 or more. So it took 4 years, and that's it. And if you wanted to check your answer, you could just take the initial, which is 2,200, and multiply by 1.11, that's the multiplier, to the power of 4. And you can see that that one's going to be greater than 3,200, but if that was to the power of 3, it'd be less than 3,200, so it would take 4 years. Okay, let's look at our next question, question number 5. So question number 5, it's a non-calculator question, so I'm just putting down my calculator reluctantly, so I've just put it down. And it says that Natalie invests £600 for 2 years at 10% per year compound interest. So it's quite a nice percentage there, 10%. And the question is work out how much interest she earns. So we want to work out how much interest she earns. So initially she put £600 into the bank. Now it increases by 10% per year. So after 1 year, we'd increase this by 10%. So we would do 600 divided by 10 to find out what 10% is, and that's equal to 60. So that's £60. So we'd do 600, how much money she put into the bank, plus the £60 interest, and that'd be equal to £660. So after 1 year, Natalie would have £660 in the bank. It increases by 10%. Now after 2 years, we're now going to increase that by 10%. So we're going to take £660 and divide it by 10, and that's equal to £66. So she earns a little bit more interest in that second year. And then if we do 660 plus £66, that's equal to £726. So that's how much money she would have in the bank after 2 years. Now the question says how much interest does she earn? So she's got £726 in the bank, but initially she put in £600. So the amount of interest that she earned would be £126. So that's it. She earns £126 in interest. She earns £60 in the first year and another £66 in the second year, and altogether that'd be £126. Okay, let's look at our next question, question number 6. So question number 6 says Margot buys a new boat, and the value of the boat, which is V pounds, is given by the formula V is equal to 48,000 multiplied by 0.88 to the power of t, where t is the age of the boat in years. And part A says write down how much the boat cost Margot. So how much did it initially cost, because obviously she buys a new boat. Now whenever we're dealing with compound interest, we can use this formula where we've got initial, so the initial value, multiplied by the multiplier to the power of time. So that formula can be very useful. Now if we have a look here, we've got the 48,000. So the 48,000 will be the initial value of the boat. So it's going to be 48,000. So that's how much Margot paid for the new boat. And then part B says write down the annual percentage decrease in value of the boat. So let's have a look at the multiplier, because the multiplier will tell us if the value of the boat is going up or down. If the multiplier is greater than 1, then then the value of the boat is going to be going up, it's going to be increasing. If the value like here is 0 point something, then it's going to be decreasing. So let's have a look at this multiplier, 0.88, that's the multiplier. Now if you multiply something by 0.88, you're decreasing it by 12%. So that means whenever you multiply by 0.88, you're going to be finding 88% of the original value. So it's going to be decreasing by 12%. So if you multiply something by 0.88, you're decreasing it by 12%. So the annual percentage decrease in value of the boat is 12%. Every single year, the value of this boat is decreasing by 12%. Okay, and then let's carry on. We're then told that Margot plans to sell the boat when it is 10 years old. How much should Margot receive for the boat? So we've got the initial, which is 40,000, multiplied by 0.88 to the power of. So she's going to be selling it for its value, so we're going to then put to the power of 10, because that tells the value of the boat after 10 years. So if we work this out in our calculator, 48,000 multiplied by 0.88 to the power of 10, that's equal to 13,368.04685. And let's just round that to 2 decimal places. That'll be £13,368 and 5 pence. And that's how much Margot should receive for the boat. And that's it. Okay, let's look at our next question. Okay, so let's have a look at question number 7. So question number 7 says, Jenny invests £400 for 2 years at 5% compound interest paid yearly. And Tim says the interest Jenny will receive will be £40. Is Tim right? Explain your answer. Okay, so let's work out how much interest Jenny should earn. So she invests £400 at 5% compound interest for 2 years. So she has £400 to begin with, and let's work out how much money would be in the account after 1 year. So after 1 year, so after the first year, so it would go up by 5%, so we're going to increase this by 5%. So 10% of £400 would be equal to £40, so that's £40. But it's 5%, so we're going to half that, so half of 40 would be £20. So that means the 5% of £400 is equal to £20. So what we've done there is we've worked out what 5% is by dividing by 10 to find 10% and then halving it. So after 1 year, that means there'd be £420 in the bank account. Now, Tim says that the amount of interest that Jenny will receive will be £40. What he's done then is he's doubled the £20 to be £40. But that's not going to be right, because after the second year, because it's compound interest, the amount of interest will go up, because 10% of 420, so 10% of 420 would be equal to 42, dividing it by 10. And that means that 5% of 420 would be half of that, which is equal to £21. And then if we add that on, so if we do 420 plus the £21 interest that she receives in the second year, would be £441. So that means that Jenny receives £41 interest, because she started off with £400. She's now got £441. So overall, over the 2 years, she receives £41 of interest, not the £40 that Tim says she should receive. So let's explain that. And that's it. I've just explained that no, she should receive £41 interest, not £40 interest. Okay, let's look at our next question, question number 8. So question number 8. Question number 8 is a calculator question, so we can use your calculator again. That's great. And we're told a bank has an investment account that pays compound interest at the rate of 4.25% per annum. So every single year, the money in the bank account goes up by 4.25%. And Mrs. Kennedy invests £2,400. And the question says, work out how much her investment is worth after 8 years. So remember, we've got the initial, which is 2,400. Multiplied by the multiplier. So its interest is going up by 4.25%. So if we start off with 100%, if it goes up by 4.25, we would have 104.25%. And as a decimal, that'll be 1.0425. So if you multiply something by 1.0425, it increases it by 4.25%. And then to the power of time, well, it's invested for 8 years, so to the power of 8. And if we just type that into our calculator, 2,400 multiplied by 1.0425 to the power of 8, that's equal to 3,348.264443. And if we round that to 2 decimal places, that'll be £3,348 and 26 pence. And that's it. That's how much money her investment will be worth after 8 years. Okay, let's look at our next question, question number 9. So question number 9. So question number 9 is about a tennis ball being dropped and it bounces and rises again. And we're told that the ball rises to 60% of the height from which it was dropped. And the ball's dropped from a height of 2 meters. So if it's dropped from a height of 2 meters, so it's dropped from a height of 2 meters, it goes down, it hits the ground and it bounces up to a height of 60% of the 2 meters. So every single time it bounces, it goes up to 60% of the previous height. And we've been asked to work out the height that it rises after its first bounce. So we know it's 2 meters to begin with, and if we want to work out how high it rises after the first bounce, we just need to work out 60% of that. So 60% of 2 meters. We can just do 2 multiplied by 0.6, or you could do half of it and add on 10% if you wanted to. But if we do 0.6 times 2, that's equal to 1.2. So that's 1.2 meters. So it'll be 1.2 meters. Okay, next, part B. Part B says calculate the height of rise after the second bounce. So we had the initial height was 2 meters, it goes down, it bounces, it goes up to a height of 1.2 meters, so that's 2 meters to begin with, it goes up to a height of 1.2 meters, and then it goes down again, and then it goes up. So it's bounced once, twice, and it's gone up to this height. And to work out this height, we just need to do 60% of 1.2 meters. Every single time we just work out 60% of the previous height. So if we do 1.2 multiplied by 0.6, that'll tell us 60% of it. So if we do 1.2 multiplied by 0.6, that's equal to 0.72. That's equal to 0.72. So it rises the height of 0.72 meters. So that would be 0.72 meters. So that's fantastic. So, okay, so it starts off at 2 meters, it falls, it bounces, it rises to 1.2 meters, it falls again, bounces and comes up to 0.72 meters or 72 centimeters, and so on. And by the way, we could actually make a formula for this. We could do the initial, which is 2 meters, multiplied by the multiplier. Because it rises to 60% of the previous height, we could do 2 meters multiplied by the multiplier, which in this case would be 0.6, because every single time it's 60% of the previous height, to the power of n, where n's the number of bounces. And that would tell you the height that it rises after that number of bounces. Again, if we carry on, and then we're told the ball carries on bouncing and each time rising to 60% of the last rise. And part C says, for how many bounces will the ball rise to a height of greater than 20 centimeters? And to show you're working. So we had 2 meters, and then 1.2 meters, and then 0.72 meters. We could just keep on multiplying by 0.6 here. So we could times by 0.6. That's equal to 0.432 meters. So that's greater than 20 centimeters, which is 0.2 meters. We could times by 0.6 again, which would be 0.2592 meters, which is 25.92 centimeters, which again is greater than 20 centimeters. We could times by 0.6 again, which would be 0.1552 meters, and that's it. So the question said, for how many bounces will it rise to a height greater than 20 centimeters? Okay, so it started off with 2 meters. After 1 bounce, it went to a height of 1.2 meters. After 2 bounces, it rose then to a height of 0.72 meters. After 3 bounces, it rose to a height of 0.432 meters. After 4 bounces, it rose to a height of 0.592 meters. And then the 5th bounce, it doesn't actually rise to a height greater than 20 centimeters, so the answer is 4. 4 bounces, it rises to height greater than 20 centimeters, and that's it. Also remember, we could have used the formula. We could have done 2 multiplied by 0.6 and then just change the power for the number of bounces and find out when it's still greater than 0.2 meters or 20 centimeters, and that's it. Okay, let's look at our next question. Question number 10. So question number 10 says the number of people living on a remote island is expected to decrease by 2% each year, and the population of the island is 28,000. And we're asked to work out the expected population on the island after 6 years. Okay, so here let's start off with the initial, which is 28,000, multiplied by the multiplier. So the population decreases by 2% each year. So that means the multiplier, well, if it decreases by 2%, you're left with 98%. As a multiplier, that would be 0.98, because if you multiply something by 0.98, you decrease it by 2%. And then to the power of 6, because it's after 6 years. So if we do 28,000 multiplied by 0.98 to the power of 6, that's equal to 24,803.586, and so on. Now, we're talking about the population of the island, so we could round this to the nearest whole number to be 24,804 people. Or you might say, well, if a bit of another person's leaving, that person might leave, so you could write 24,803. Either one of these would be accepted in this question. And that's it. Okay, let's look at our next question, question number 11. Okay, so question number 11. Question number 11 says the value of a television was £600 on the 1st of March 2025. And every 4 months, the value of the TV decreased by 8% of its value at the start of that 4-month period. And we've been asked to work out the value of the television on the 1st of March 2026. So that's 1 year later. Let's write down our formula. We've got initial, which is 600, multiplied by the multiplier. Well, it's decreasing by 8%. So if you want to decrease something by 8%, you multiply by 0.92 because you're left with 92%. And then to the power of time. Now here we're not going to write 1 here, we're not talking about years because we're told that it decreases by 8% of its value at the start of that 4-month period. So every single 4 months it decreases by 8. And in 1 year, which is 12 months, there's going to be 3 lots of 4 months. You've got 4 months, another 4 months, and another 4 months. That'll be your whole year period because your first 4 months would bring you to the first of April, May, June, July. That'll be the first 4 months. Then the next 4 months would be August, September, October, November. So then the 1st of November you'd have to the power of 2. And then to the power of 3 would be December, January, February, March. So that'll be 3 lots of 4 months. So it's going to be to the power of 3 because you've got 3 lots of 4 months in that time scale. Okay, so we just need to work this out. So we're going to do 600 multiplied by 0.92 to the power of 3. Another way you could do is actually break it down and multiply by 0.92 to find out how much it would be worth on the 1st of April, May, June, July. You can multiply by 0.92 to work out how much the television would be worth on the 1st of August, September, October, November, the 1st of November, and then you could multiply by 0.92 to work out the value of the television on the 1st of March 2026. But I probably would just do it in one go like this and get the answer. So let's type that into our calculator. We've got 600 multiplied by 0.92 to the power of 3. And that's equal to 467.2128. And because we're dealing with the value of a television, I'm going to round that to the nearest penny, so that'll be 467.21. I'm going to just round that to the nearest penny, and that's it. Okay, let's look at our next question, question number 12. Okay, question number 12. Question number 12 says that £5,200 is invested at 2.8% compound interest per annum. And we've been asked to work out how many years it will take for the investment to exceed £7,000. Okay, so we have got the initial, which is 5,200. We're going to multiply that by the multiplier. So if you want to increase something by 2.8%, the multiplier would be 1.028 because you would have 102.8%. So it'll be 1.028 as a multiplier. And then to the power of time. And what we're going to do is we're going to change that power. We're going to try 1 and 2 and so on. We're going to find the first whole number that whenever we substitute it in as a power would exceed £7,000. So let's try some values and see. So let's start off with 5 years. So let's do 5,200 multiplied by 1.028 to the power of 5, and let's see what we get. So that'll be 5 years. So 5,200 multiplied by 1.028 to the power of 5, and that's only 5,969.925 and so on. We want it to exceed 7,000, so to the power of 5, it's not big enough. So let's try a different number. Let's try it to the power of 9. So 5,200 multiplied by 1.028 to the power of 9. And when we do that, we get an answer of 6,667.1676 and so on. And again, that's not exceeding 7,000. So let's now try it to the power of 10. So 5,200 times 1.028 to the power of 10. And let's see what we get there. So if we change the power from a 9 to a 10, we now get that's equal to 6,853.84 and so on. So again, not exceeding 7,000. So let's now try 11. So 5,200 multiplied by 1.028 to the power of 11. And then that's equal to, fantastic, 7,045.756 and so on. And that has now exceeded 7,000. And it's very important here, we've got the 10 was below 7,000 and we've got 11 is above 7,000. It's important that you get the first one that exceeds 7,000. So for instance, if I tried 5 and then 11, it's important that I go back to 10 and just check the 10 years is below 7,000. So the question is, how many years will it take for the investment to exceed £7,000? Well, after 11 years, the value of the investment will exceed £7,000. And that's it. Okay, let's look at our next question, question number 13. Okay, let's have a look at our next question, question number 13. So question number 13 says, Barnaby bought a new motorbike for £30,000 and he believes the value will depreciate by 25% each year. So he's saying that the value of the motorbike is going to go down by 25% each year. And part A says, what should the value of the motorbike be after 2 years? Okay, so he's saying it's going to go down in value by 25% of its value each year. So that means we could use a formula. We could do 30,000 multiplied by, and if it goes down by 25%, we'll be left with 75%, so that'll be 0.75 to the power of, and it's going to be 2 years, so to the power of 2. Or you could just take the £30,000 and reduce it by 25%, get that answer, and then reduce that by 25% to find out how much it'd be worth after the second year. So if we do 30,000, so 30,000 multiplied by 0.75 squared, that's equal to £16,875. So that's how much the motorbike should be worth after 2 years, £16,875. Okay, and then if we go on down, and then if we carry on, we're told for the model of motorbike the Barnaby bought, it actually depreciates by 22% each year. So it doesn't actually go down by 25% each year, it actually only goes down by 22%. So perhaps his model's a bit better than the one that he was initially looking at because it holds a bit more of its value. And then part B says, how does that affect our answer to part A? Well, in terms of part A, well, our answer to part A is how much the motorbike's worth after 2 years. But that's based on it going down by 25% of its value each year. But if it's only going down by 22% of its value each year, well, it's going to be worth more because it's not going down by as much. So let's explain that. And that's it. I've just explained that it will increase this answer to part A, the value of the motorbike. It won't actually be as low as 16,875. It'll be a bit more than that. So this answer to part A will increase. It'll go up a little bit as the value is only decreasing by 22% each year, not 25%. Okay, let's look at our next question. Okay, so question number 14. So question number 14 says that Sean invests £8,000 for 4 years in a savings account that pays compound interest. In the first year, the interest rate is 6%, but then for every other year, the interest rate is 2.5%. So there's a promotional interest rate for the first year of 6%, and then 2.5% for all the other years. And the question says, work out how much money is in the account at the end of 4 years. Okay, so this is a calculator question, so that's quite nice. So what we're going to do is we're going to increase the amount of money in the bank account by 6% because that'll tell us how much money is in the bank account after 1 year. So we're going to do 8,000 multiplied by 1.06 because that'll increase it by 6%. That's our multiplier. And then in terms of the power, because it's just for 1 year, I'm just going to write this down, but I could, if I wanted to, write to the power of 1. And when we do 8,000 multiplied by, so 8,000 multiplied by 1.06, that's equal to £8,480. So that's how much money will be in the bank account after 1 year. Now Sean's investing the money in the bank account for 4 years, so there's going to be another 3 years. So now what we're going to do is we're going to do the initial. Now I'm going to consider this 3-year period on its own here, so I'm going to consider the initial at the start of that 3-year period would be £8,480. Multiplied by the multiplier. Now, if we're increasing by 2.5%, we then have 102.5%, so that'd be 1.025 as a multiplier. If you multiply something by 1.025, it increases it by 2.5%. And then to the power of 3, because it'll be 3 years at this interest rate. So if we do £8,480 multiplied by 1.025 to the power of 3, that's equal to 9,132.0325. And we've been asked how much money is in the bank account at the end of 4 years. That'll be £9,132. And I'm going to round this to the nearest penny, so 0.03. And that's it. So how much money is in the account at the end of the 4-year period? The answer would be £9,132 and 3 pence. And just to recap that, what we done was we increased by 6% to begin with for the first year. And then what we done was we considered the next 3 years. We used that as our initial. We then had our multiplier, which was 1.025, and then to the power of 3 because it was 3 years at that interest rate. And that's it. Okay, let's take our next question, question number 15. Okay, so question number 15 says, a radioactive substance decays over time, and each year its mass decreases by 14%. So this is a repeated percentage change question. We've got this repeated change by a particular percentage, but obviously we can approach it in the same way as compound interest, where we can use initial times multiplier to the power of time. So if we go back, we're told a radioactive substance decays over time, and each year the mass decreases by 14%. And the question says, how many years will it take for 500 kilograms of the substance to decay to a mass of less than 200 kilograms? Okay, so what we're going to do is we've got initial, which is 500. And then we're told it decreases by 14% each year. So if something decreases by 14%, we're left with 86%. So the multiplier would be 0.86. And then to the power of time. And in this question, we need to change the powers and find at which particular number of years will the mass decrease to less than 200 kilograms. So let's try different numbers of years. So let's try 3 years to begin with. So 3 years. So for 3 years, we'd have 500 multiplied by 0.86 to the power of 3. And when we do that, 500 multiplied by 0.86 to the power of 3, that's equal to 318.028 kilograms. Now, that's not less than 200 kilograms, so we need to try a bigger number. So I'm going to try 5 years now. So 500 multiplied by 0.86 to the power of 5. And let's see what we get. So I'm just changing the power on my calculator from 3 to 5. And that's equal to 235.213508 kilograms. So again, that's greater than 200 kilograms. So now let's try 6 years and see what we get. So 6 years. So let's change the power from a 5 to a 6. Now here I am writing this down on the page just to make sure that my method is clear to the examiner. So that's 202 kilograms, 0.2836176 kilograms. So again, that's greater than 200 kilograms. And I'm pretty sure now after 7 years, it'll decrease to below 200 kilograms. So 0.86 to the power of 7. And when we change the power from 6 to 7, the answer is now 173.96 and so on kilograms. So the question is, how many years will it take for 500 kilograms of the substance to decay to a mass less than 200 kilograms? It'll take 7 years. And that's it. So let's write that down. 7. Okay, that's it. Okay, let's look at our next question, question number 16. Okay, let's look at our next question, question number 16. Okay, so question number 16, it's another repeated change question. So we've got this repeated percentage change. So we can approach it in the same way as compound interest. And we're told it takes James 100 minutes to run a distance. So we don't know what that distance is, but it takes him 100 minutes. And his target is to run the distance in less than 80 minutes. And with training, he expects his time to decrease by 3% each month. So every single month, he's expecting his time to decrease by 3%. And the question says, does he expect to achieve his target after 6 months? Sure, you're working. Okay, so the initial amount of time taken to run the distance is 100 minutes. Then we're going to multiply that by the multiplier. Now, his time decreases by 3% each month. So if you've got 100% and you decrease it by 3%, you're left with 97%. That's 0.97. So that's the multiplier, 0.97. If you multiply something by 0.97, it decreases by 3%. And we want to know, does he achieve his target of less than 80 minutes after 6 months? So to the power, because it's 3% each month and it's 6 months, it's going to be to the power of 6. So if we do 100 multiplied by 0.97 to the power of 6, that's equal to 83.297 and so on minutes. So does he achieve his target? Well, his target is to run it in less than 80 minutes, and this isn't less than 80 minutes. So the answer is no, he doesn't. So the answer is no, he doesn't achieve his target. He's done quite well. He's actually reduced his time from 100 minutes down to 83.297 minutes, which is fantastic, and he should be proud of himself, but he hasn't achieved this target of less than 80 minutes yet. Okay, let's look at our next question, question number 17. Okay, so question number 17. Question number 17 says that Sophie invests £400 in a savings account that pays 3.5% compound interest per year. And she wants to earn at least £500 interest. So she wants to earn £500 interest. So that means she wants to change her £400 into £900, because if she has £400 to begin with and she earns £500 interest, that means that she's going to have £900 in the account. That's what she wants. She wants to earn at least £500 interest, which means she wants to have at least £900 in the account. And the question says, how many years will that take? Okay, so I'm going to guess it's going to take quite a long time to go from £400 up to £900 at 3.5% compound interest. But let's try that and see. So we've got initial, which is £400, times the multiplier, which is 1.035. If you increase something by 3.5%, you'd have 103.5%. So it's going to be 1.035 as a multiplier. And then to the power of time, and we're going to change the number of years here. Now, I think it's going to be quite a large number. So I'm going to try 20 years to begin with and see, over 20 years, will the £400 become £900 and therefore earning her at least £500 interest. So we've got 400 multiplied by 1.035 to the power of 20. So 400 multiplied by 1.035 to the power of 20. And that's equal to £795. 0.915 and so on. So that's quite a big increase, but it's not quite the £500 interest that she wants. It's only £395 interest. Okay, so let's try another number. I'm going to try 25 years. So 25 years. So that's 400 multiplied by 1.035 to the power of 25. So my calculator, I'm just changing the 20 to 25. So that's equal to 945.2979 and so on. So that's more than £900, which is fantastic. And so that means that over 25 years, she'll earn a £545 interest. But we want to work out the least number of years it'll take. It says how many years will it take for her to earn at least £500 interest. So let's try a smaller number. I'm going to try now 23 years and see what 23 years would be. So that's 400 multiplied by 1.035 to the power of 23. And let's see what we get. So changing it from 25 to 23 is 882.44 and so on. So that's not the £500 interest as you wanted, only £482 interest. Now let's try 24 years because perhaps 24 years sneaks in there. So let's try 400 multiplied by 1.035 to the power of 24. And let's see if that sneaks in. So if we do change the power from 23 to 24, that's it, £913.33p to the nearest penny. So that means that over 24 years, she would earn £513.33p of interest, just taking away the £400 she initially invested. So 23 years wasn't enough, 24 years was enough, but we actually tried 25 years, which was actually too far. So the question is, how many years will it take for her to earn at least £500 interest? The answer is 24 years, and that's it. Okay, let's look at our next question. So question number 18 says Aurora wants to invest £500 and she's got two options, Bank World or Bank Universe. And we're told that Bank World pays 8% compound interest per year and Bank Universe pays 9% simple interest per year. So we've got compound interest here and simple interest. So compound interest is where it increases by 8% of its value each of the years. So we'll go up by 8% in the first year, then we'll take that new value and work out 8% of that and add it on, and that'll be how much it'll be worth after 2 years. Then we'll work out 8% of that new amount and then add that on and so on. So we're earning interest on the interest. In terms of Bank Universe, it pays 9% simple interest per year. So that means that we work out 9% of the initial amount invested and then just add that on every single year. And then we're asked which bank is the best choice if Aurora wants to invest her money for 4 years and you must show you're working. Okay, so let's start off with Bank World. So Bank World. So Bank World, we're going to use our compound interest formula, which is the initial, which is £500. Multiplied by the multiplier. Well, it's going up by 8%, so it'll be 1.08. If we multiply something by 1.08, we increase it by 8% to the power of time, which in this case is 4 years. And then if we work that out, if we do, just get the calculator. Just get my calculator, 500 multiplied by 1.08 to the power of 4, that's equal to 680.244 and so on. So the nearest penny, that'll be £680 and 24p. Okay, now let's have a look at Bank Universe. It pays 9% simple interest per year. So that means that she starts off with £500. So if we take the £500 and we work out 9% of it, so I'm going to divide it by 100 to find 1%, which is £5. And I'm going to take the £5 and times that by 9, and that's equal to £45. So that means that Bank Universe pay £45 every single year in terms of the interest because it's simple interest. So we're going to take the £45 and we're going to multiply that by 4 because it's invested for 4 years. So 45 multiplied by 4 is equal to £180. So that's £180. So that's how much interest she earns. Now if we add that on, so 500 plus 180 is equal to £680. So that means that if she invests her money for 4 years in Bank World, she would have £680 and 24p. If she invests it into Bank Universe, she'd have £680. So the question says, which bank should she choose if she wants to invest her money for 4 years? Well, the answer would be Bank World, because she'd have more money in Bank World than Bank Universe. And that's after 4 years, and there's only 24p of a difference there. But after 5 years, 6 years, 7 years, and so on, you'll actually notice that Bank World will actually start excelling, and there'll be a bigger difference, and Bank World will actually be outperforming Bank Universe. You might find after 1 year or 2 years, the Bank Universe might be the best choice, but if she's going to invest it for 4 years, the best choice there would be Bank World. And that's it. So let's write that down, Bank World. And that's it. She should invest her money in Bank World. Okay, let's look at our next question, question number 19. Okay, so question number 19. Question number 19 says that Kelly and Tim invest £6,000 for 5 years. And there's Banks R Us and Corbett Bank. And Banks R Us pay 3% per year compound interest. And Corbett Bank pay compound interest. It pays a promotional 11% for the first year and then only 0.9% interest for additional years. And Kelly invests her money in Banks R Us and Tim invests his money in Corbett Bank. And the question says, who will have the most money at the end of the 5 years? Okay, so let's start off with Kelly at Banks R Us because it's actually a little bit easier. So Banks R Us. So Banks R Us, it's going to be the initial amount of money. Let's just go back up there. It was £6,000 and it's for 5 years. So £6,000 is the initial, so 6,000 multiplied by the multiplier. Well, Banks R Us pay a compound interest of 3% per year. So to increase something by 3%, you'd multiply by 1.03. And then to the power of 5 because it's 5 years. So if we do 6,000 multiplied by 1.03 to the power of 5, that's equal to £6,955 and 64p to the nearest penny. So that's how much money Kelly will have if she invests her money in Banks R Us for 5 years. Okay, now let's have a look at Tim. And I'm going to just change colour of ink here to blue just so it stands out a bit more. So Tim invests his money in Corbett Bank and it pays 11% for the first year. So what I'm going to do is I'm going to take the £6,000 and I'm going to increase it by 11% to begin with. So just deal with that first year to begin with. So I'm going to multiply by 1.11. If you multiply something by 1.11, you increase it by 11%. So 6,000 multiplied by 1.11 is equal to £6,660. So that's how much money Tim will have after 1 year. Now he does invest it for 5 years. Now we're told for each of the additional years, the Corbett Bank pay 0.9% compound interest. So what we're going to do is now we're going to consider the next 4 years. We've dealt with 1 year, there's 4 more years. So in terms of the initial amount of money at the start of that 4-year period, that would be £6,660. And then we're going to times it by the multiplier. So we're increasing by 0.9%. So if you've got 100%, if you increase it by 0.9%, you would have 100.9%. So that'd be 1.009. And then to the power of 4 because it's 4 years. So if we do 6,660 multiplied by 1.009 to the power of 4, that's equal to £6,903 and 2p to the nearest penny. So that's fantastic. We've now worked out how much money Tim would have if he invested his money in Corbett Bank. Now the question says who will have the most money at the end of 5 years. So let's compare them. So as you can see here that Kelly would have more money in Banks R Us than Tim. So let's write that down. So I've just written down that Kelly would have more because she would have £6,955 and 64p, but Tim would only have £6,903 and 2 pence. And they're rounded to the nearest penny. Okay, so that's it. That's question number 19. Let's have a look at question number 20. Okay, let's have a look at our next question, question number 20. So question number 20 says, Martin's got some money to invest and he sees this advert and says, Bank of Mavs, and says double your money in 15 years. And it says the average annual growth for your investment is 4.5%. And the question says, will Martin double his money in 15 years by investing his money with Bank of Mavs? And you must show your workings. Now this time we don't actually know how much money Martin invests, but it just says, will he double his money? So we can actually let him have any amount of money to begin with. Now, with questions like this, I sometimes like to choose 100. So perhaps in this case, £100, because if you choose 100, you can actually see by how much percent it goes up by. So let's say he's got £100 to begin with. And then if we multiply that by the multiplier, so it's gone up by 4.5%. So that'd be 1.045. That's an increase of 4.5%. And it says it doubles in 15 years. So let's do it to the power of 15. And let's see, will this double? Will we get 200? So if we do 100 multiplied by 1.045 to the power of 15, that's equal to 193.52824443. So has it doubled? No, it's only gone up to 193.52 and so on. And if you think of this in terms of percentages and say, well, he started off with 100%, it's gone up to 193.528 and so on percent. So it's gone up by 93.52%. It's not doubled. It's not gone up by another 100%. So that's it. So let's explain our answer. And I've just written down that no, it will not double. It's only gone up from £100 up to 193.52 and so on. So that's it. So no, it will not double. I could have actually written down it's only gone up by 93.528%, which is not quite the 100% increase that it needs. Okay, let's look at our next question, question number 21. So question number 21 says that Finn invests £8,000 in a savings account that will pay X% interest, compound interest, over the next 3 years. And after 3 years, he's got £9,200 in the savings account. And we've been asked to work out X, the percentage increase, and we need to give our answer to 2 decimal places. So this question is a little bit different than the ones we've looked at so far, because we know how much he's invested, we know how long he's invested it for, we actually know how much money he's got at the end of that investment period, that 3 years, but we don't know the interest rate. So let's write down our formula. Initial, which is 8,000, multiplied by the multiplier. Now, what I'm going to do is I'm just going to call that Y here to begin with, Y. And then we've got to the power of time, which in this case is 3, and that's equal to 9,200. So what we've done there is we've substituted in our values, the initial. We don't know the multiplier, so we've just called it y. I've not called it x because I don't want to get confused with the multiplication sign. I could call it x if I wanted to, make it a bit more curvy, but I've called it y. Cubed because it's to the power of 3, 3 years. And then we've got that's equal to £9,200. Now what we've got here is we've got an equation. We just need to solve it. I'm going to divide both sides of the equation by 8,000, and then I'm going to cube root to get rid of that cubed. So let's divide both sides by 8,000. So if we divide both sides of the equation by 8,000, we'll be left with on the left-hand side, y cubed. And on the right-hand side, if we do 9,200 divided by 8,000, that's equal to 1.15. Now that's y cubed. We want to find out what y is, the multiplier, because once we find the multiplier, we can then work out the percentage compound interest that's paid. So let's work out the cube root of both sides. So we're going to get the y is equal to, and we're going to do the cube root of 1.15. And when we do the cube root of 1.15, we get that's equal to 1.0476895553. So that means that our multiplier is 1.0476895553. Now what we want to do is we want to work out the percentage here, x, because x is the percentage compound interest. So we need to work out how much it's gone up by each year. So this will be a 4.7689 and so on percent increase. Now we need to give our answer to 2 decimal places. So I'm just going to write down the percentage to begin with. So it'll be 4.76895553%. And then I'm going to round this to 2 decimal places. So that'll be 4.77. So that would be 4.77. So that means that x is 4.77%. And that's it. So that's question number 21. Okay, now let's have a look at question number 22. Okay, question number 22. We're told that a fish tank has sprung a leak at the base of the tank, and 5% of the water is lost every minute. How much water is lost from the tank after 10 minutes? So this question is a repeated percentage change question, but we can approach it in the same way as compound interest, where we use the initial. Well, we don't actually know the initial amount of water in the tank here. So what I'm going to do is I'm going to let it be 100% because we're going to say it's full. It's 100%. And then we're going to multiply by the multiplier. Now it's losing 5% of its water every minute. So the multiplier would be 0.95. If you multiply something by 0.95, it decreases it by 5%. And then it's every minute, and it says how much water is lost after 10 minutes. Well, let's then call that to the power of 10. So we've got the initial, which is 100% of the water, multiplied by 0.95 because it's going down by 5% each minute, and then to the power of 10 because it says after 10 minutes. And if we do 100 multiplied by 0.95 to the power of 10, that's equal to 59.873 and so on percent. So that's how much water is left in the tank after 10 minutes. Now we want to work out how much water is lost from the tank. So we need to take that away from what we started with. So we had 100% to begin with. This is what percent is left after 10 minutes. So we need to take away the 59.873 and so on. And I've still got that on my calculator display. So I'm just going to type in answer. So I'm just going to type in 100, subtract answer is equal to 40.1263 and so on percent. So how much water is lost from the tank after 10 minutes? Well, 40.126% to 3 decimal places. And that's it. So that's what percentage of water is lost from the tank after 10 minutes. And that's it. Okay, let's look at our last question, question number 23. So question number 23 says that Carol invests £7,000 in a savings account that pays a constant rate of compound interest. And after 2 years, there's £8,316.70 in the account. And the question says, work out how much money will be in the account after 3 years. So we know how much money is in the account after 2 years. We want to work out how much money will be in the account after 3 years. So this question is a bit like question number 21. If we go back to question number 21 with Finn, the only thing is that this time, rather than just trying to work out the percentage, we actually then need to work out how much money is going to be in the account after 3 years. Okay, so let's use our formula, initial, which is £7,000. Multiply by the multiplier. Now we don't know the constant rate of compound interest. We don't know this. So I'm just going to call it y. We've got times y to the power of time. So it's invested for 2 years. So to the power of 2. And that's equal to £8,316.70. So that's fantastic. Now if we solve this, we can find out what y is, our multiplier. And then if we know what the multiplier is, then we can work out how much money is in the account after 3 years. So let's divide both sides of the equation by 7,000. So we're going to get on the left hand side y squared, and on the right hand side 8,316.7 divided by 7,000 is equal to 1.1881. So that's what y squared is. Now we want to find out what y is here, so we're going to square root. Now obviously here we've got y squared, so if you're solving an equation with y squared equals a number, you would get a plus and a minus the square root of this. But in this situation, because it's a multiplier, it can only be the positive value, so I'm just going to ignore the negative solution here. So I'm going to do the square root of this, and that's equal to 1.09. Just to recap that, if you had something such as w squared equals 25, that means that w would be equal to 5 or negative 5, because you could have 5 squared or negative 5 squared. But here, the negative solution of this wouldn't make any sense because we're dealing with this compound interest question. Okay, so we've got the y is 1.09. So that means that it's paying 9% compound interest. It's paying 9% a year, because if the multiplier is 1.09, it's increasing by 9% each year. But the question says, how much money is there going to be in the account after 3 years? So what we could do is we could take this amount of money and just increase it by 9%, because if we know how much money is in the account after 2 years, if you just increase that by another 9%, so times this by 1.09, so you can just times 1.09 and get the answer there. And if you do 8,316.7 times 1.09, that's equal to £9,065 and 20p to the nearest penny. It was actually 0.203, but I've just rounded that to the nearest penny. So that means that's how much money Cahill will have in the account after 3 years. Or alternatively, you could go back and do the initial, which is £7,000, times the multiplier, 1.09, to the power of 3, because it's 3 years. And if you work that out, 7,000 times 1.09 to the power of 3, I don't know why I'm typing it, because I know I'm going to get the same answer, which is 9,065.203. And if we round that to the nearest penny, that'll be £9,065 and 20 pence. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on compound interest. I really hope you found this video useful. If you have found it useful, please like and please subscribe to my YouTube channel. Also, if you know anyone that might find the Corbettmaths resources useful, please feel free to share the Corbettmaths resources with them. So perhaps a friend might need a bit of extra help with their maths, so please recommend Corbettmaths to them. Perhaps your teacher might find some resources useful, so recommend Corbettmaths to them, and so on. Also, just to mention that if you need any extra help on compound interest, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video number 236, there's a dedicated video tutorial there on compound interest, and if you watch that, that'll be useful for you as well. But that's it. So I just want to say thank you very much for watching this video. Thank you for liking it, thank you for subscribing, and all the best with your studies. Thank you. Cheers. Bye.